2.3 is solving radical equations graphically. So it says radical equations can be solved graphically or algebraically. Algebraic solutions sometimes produce extraneous roots, where graphical solutions do not. So basically, when you're looking at a graph, you can tell right away what doesn't work, whereas when you're using algebra or basically math skills to solve it, you can't always pick out the extraneous roots right away. It says, however, algebraic solutions are generally exact, while graphical solutions are usually approximate. So if you think of in the last section in 2.2, when we did the square root of 2, we rounded it. We didn't give an exact value. You can solve equations, including radical equations, graphically by identifying the x-intercepts of the graph of the corresponding function. So it says, use a graph to locate the x-intercepts of the graph y is equal to the square root of x plus 2 minus 4. So if we take a look at our graph, remembering that our general form looks like that. So for this one, our a value is equal to 1, b is equal to 1, h is equal to negative 2, and k is equal to negative 4. So it means from our original graph, remember our parent graph or our basic graph would be this. We're going to apply these transformations. Okay, so for y is equal to the square root of x, those occur at 0, 0, 1, 1, and the basic ones we do are up to 4, 2. So 1. You could go as far as 9 and 3. Maybe we'll put that one on here just to have. So y is equal to square root of x looks like that. So now if we apply our transformations, our a is 1, so we don't have any vertical stretch. B is 1, so we don't have a horizontal stretch, and there's no negatives, so we don't have any flips happening. So we're going to move down from 0, 0. It's now going to occur at negative. We're going down 2, or over 2, and down 4. So right here is where we're going to start this graph. So if we're starting there, then that means our next point. And you could either do your translations from here, so I could go 1, 2, down, 1, 2, 3, 4. Or just apply, okay, I know I'm at, pretend this is your 0, 0, so then it's 1, 1, and it's going to be 4 and 2. And then our 9 and 3. Or I could do my translation. So this one I went over 2, down 4. So you get the same idea. Okay, but when I did this, you can see I still don't have my next point, because my transformation, I didn't put enough on there to see it. So the next one would be at 16, and 4 would be, this should be in blue, so this would be 16 and 4 would be my other point out here. So it's going to be, well, I curved a little bit too much. Well, that's not even right either. Let me do this. 16 and 4 will be somewhere out here, we'll say. So if I apply my transformations to that, my next one is going to be at, if I take 2 away from here, that's going to be at 14. If I take 4 away from there, it's going to be at 0. So that's where my x-intercept is. So my x-intercept would have been at 14. Oh, which is right on the edge of my graph here, 14, 0. So this graph here would have continued on through there. So basically what you need to do is if your original graph doesn't give you enough points to transform to do it, all you need to do is apply your transformations to your coordinates. Okay, so I know I have 16 and 4. My next point would have been at 25 and 5, 36 and 6, and so on. So then I would just apply my h and k value to those to find my point. So the x-intercept for this one occurs at 14 and 0. It says algebraically determine the roots of the equation y is equal to x plus square root of x plus 2 minus 4 equals 0. So the first thing we want to do is remember our steps for solving things algebraically. So first we want to list all the restrictions on the variable. So that's the same as your NPVs if you want to think of it that way. We've done lots with NPVs last year. So to find the restriction, I take whatever under the radical sign and put it greater than or equal to 0 because I don't want it to be a negative value. So then that means x has to be greater than or equal to 2. Step number 2 says isolate the radical and the square and square both sides of the equation to eliminate the radical. So this is just solving for that equation. This shouldn't have a y equals there because I'm saying it equals 0. I want to find where that x-intercept is. That's solving. Finding x-intercept, finding your solution, all means the same thing. So I have x plus 2 minus 4 equals 0. Square root of x plus 2, sorry. So then this becomes square root of x plus 2 is equal to 4. I square both sides. X plus 2 is equal to 16. Subtract 2. X is equal to 4. So this is steps 2 and 3. So it says check the solution by subbing it into the equation and checking it against your restriction. So if I check it against my restriction, 4 is greater than negative 2, so that works. If I check it into my solution there, or to my equation, so that's that left side, right side check. So I have square root, well that should be a 14, not a 4. Square root of 14 plus 2 minus 4 needs to equal 0. So I have square root of 16 minus 4. 4 minus 4 equals 0. So I know it works. So C says, describe the relationship between your findings in part A and part B. So our solution to this algebraic method is the same as the x-intercept when we drew it on the graph. So the algebraic solution is the same as the graphical solution. So it says, solve the equation 4 minus x is equal to square root of 6 minus x, both graphically and algebraically. Okay, so if we're going to do this algebraically, I'm just going to see which one I'm going to do first. Yeah, I'll do it algebraically first. So step number 1 says I have to identify any restrictions. So 6 minus x is greater than or equal to 0. So 6 is greater than or equal to x, or x has to be less than or equal to 6. So I can use any value from 6 and down. So the second part then is we want to solve. So I have 4 minus x is equal to the square root of 6 minus x. So my radical is already isolated by itself, so I can do the next step of squaring. This is where people are going to make mistakes, because you have to remember when you square a binomial, you end up with a trinomial. You need to have 3 terms. So your steps are, the shortcut steps are, square the first term, so 4 squared is 16. Multiply all of your terms together. So 4 times negative x is negative 4x, and then I double it because of my 2, so that becomes a minus 8x. And then the last step is to square the last term, so negative x squared becomes plus x squared. And on this side I just have 6 minus x. So I bring everything over to one side in order to solve. So I'm going to subtract 6 and add x. So I'm going to have, I'm just going to put it in order. I'll have x squared minus 7x plus 10 is equal to 0. So now you have to solve that. So you can use quadratic formula, or when it's easy to do, you do factoring. So this is just product and sum. I need a product that adds up to 10 and, that multiplies to 10 and adds to negative 7, so that's negative 5 and negative 2. So I have x minus 5 times x minus 2 equals 0, so x is equal to 5 when I solve that, and x is equal to 2. X minus 5 equals 0, x equals 5, so where I got that from. Okay, so I have x is equal to 5, and x is equal to 2. So I have to then check. So when I check this side, I have 4 minus 5 is equal to the square root of 6 minus 5. So I have negative 1 is equal to square root of 1. Negative 1 is equal to 1. So this one doesn't work. So I'm throwing that one out. So now I have to check the next one. X is equal to 2. So I have 4 minus 2 is equal to the square root of 6 minus 2. 4 minus 2 is equal to 2. Square root of 6 minus 2 is equal to 4. Oops. Get rid of the square root. So 2 is equal to 2. So I know that this is a solution. And remember to always circle it or put a square around it or identify it somehow as being the solution that you have. So this one here, my solution where I tried 5 doesn't work, so it's an extraneous root. It still fits in within my restrictions that I had there because it is less than 6. But because it leaves me with a funny value, I can't use that one. That's why it's an extraneous root. Okay, so this was algebraically. If I want to do this graphically, okay, so what I do then is I look at my equation. So I've got basically 2 equations here. I have equation 1 and equation 2. So my y1 is equal to 4 minus x. So that means my slope is negative 1 and my y-intercept is equal to 4. So I can graph that one easily. 1, 2, 3, 4. And then negative 1 slope, so I'm going to go down 1 over 1. And this way I'd be going up 1 over left 1. Okay, so I'm going to put one more here. Draw my line through here. Okay, so that was my first graph. So now for my second graph, my y2, I have square root of 6 minus x. So that's like saying negative x plus 6. So this negative is right beside the x, so that means I have to factor it out. So that becomes negative x minus 6. It would be no different than if I had 2x plus 6. I'd have to factor out the 2 to get 2 times x plus 3. So if I take a look at this, my a value is equal to 1. My b value is equal to negative 1, so that means it's going to reflect. It's affecting the x value, so it's going to reflect in the y-axis. H is equal to 6, and my k is equal to 0. Okay, so my original graph, and I'll just do that in blue, would be this one here going 1, 1, 1, 2, 3, 4, 2, like that. So this one means I have to reflect it. So it's going to be going in the opposite direction. And I'm moving over 6. So 1, 2, 3, 4, 5, 6. And then I will have my points from there. So my 1, 1, and then 1, 2, 3, 4, 1, 2. So the point where my graph crosses, my two graphs cross, is a solution. So if I take a look here, my graph crosses there. That point is at 2, 2. Okay, and my extraneous root, if I think of it on this graph, that point 5, if I had substituted 5 into there, 5 in my solution, so I would have been moved over, and I'd be down here in those negative spots. So that's why I can't use that negative value, or I can't use that value of 5. So this is a good example of where the graphical solution was better, because you could tell right away, well, I can't have negative values in there, so I can't go past that. Or I can't use that 5 value. I shouldn't say can't go past it. I can't use that 5 value because that's not part of my solution. For this one here, I just put a link to another site where there's a graphing calculator on there that you can use instead of, if you don't have your graphing calculator with you when you're working on these questions, you can just go to that site there, and there's a graphing calculator there. There's also a ton if you just Google search them online. They're not the TI 84s or 83s, but they do the same things, just have different keys to punch. Okay, so this one says solve the equation x plus 3 is equal to square root of 12 minus 2x squared using two different methods. Oh. So method 1 is graphically. If we do this as a single function, so that means we're going to take everything over to one side and solve it, and put it in our calculator, and using two functions. So that's like we did on the other one, where one side of the equation is our y1 and the other side of the equation is the y2. So when we're doing this graphically, we're going to do it on the graphing calculator. So first I'm just going to set this up first. So if we're using it as a single function, we need to rearrange so that our equation is equal to 0. So basically what that means is I have to take this over to the other side. So I have 0 is equal to square root of 12 minus 2x squared minus x minus 3. So that is going to be then, when we put it in our calculator, our y1 equation. Okay, so I put that into my calculator. So I do second function, square root, and then I need to put in a bracket there so that everything I put under there right now, that 12 minus x squared or minus 2x squared, is all underneath the square root sign. So I've got 12 minus, not negative, 2x squared. And now I can close my bracket off. So that part there is going to be under the square root sign. Move it over. Move your cursor over, so then it's minus x minus 3. And I do my graph. I might have to change my window. Yep. I'm just going to do it between negative 10 and 10. X scale will just go up by 1. Negative 10 and 10. Oops, skip that one. Go up by 1. Okay, now let's graph it. So there's one graph, or there's our graph. So now what I want to do is I need to find out what are these 2 points that cross the graph. So I want to calculate that. So to calculate that, I do my second trace. I'm just going to graph, and then I'll put these steps on here. So you do second, and then trace, because that's calculate. Oops, I moved pages, didn't want that. Okay. So what I want to find then is my intersect. I want to see where did that graph intersect the where did it intersect the axis? So then I'm going to do number 5, which is intersect. Okay, so gave me my value there. So it says first curve at x is equal to 0, and sometimes you need to move it just a little bit. So I'm going to hit enter. Move your cursor to the other side of that x axis. Enter. Oh, didn't it enter? Second curve. Why aren't you? There we go. Oh, didn't like that. How come? Okay, I'm going to try that again. Okay, I'm just going to pause for a second because I don't know why it's not switching my... Okay, I figured out why it's not doing that, because I didn't give it another line for it to intersect. So I'm going to say my second line is at 0. So I want it just to cut through there so that I can pick out that, or so that I can do an intersection. So I'm just going to move down here. So I should have done y2 is equal to 0. So now I can graph it. And it, although you can't see it because it's right on that x-intercept, if I do my second calculate, now I do intersect. So my first curve is on x, it's on that graph, y1 is equal to that value. I'm just going to move it over a smidge. Enter. Second curve, I want it when y is equal to 0, so it's switched to that y equals 0 graph. Do my guess. Enter. So it says one intersect is going to be at 0.414, we'll say. Whoops, 414. So that's when y is equal to 0. But you can tell from my graph I have a second point, or what looks like here, a second point where my graph is crossing. So I need to do that a second time. So I'm going to go into my intersect again. I'm going to move this over here. Okay, hit enter, so that's where I want my first curve to be. So it's on the curved part. My second one is on that y equals 0, so that's my second line. So the second point was when it equaled negative 2.414. Okay, so now we want to do this using two functions. So like we did in the other one where we graphed both sides of the equation. So our equation 1 is going to be x plus 3. And our equation 2 is going to be the square root of 12 minus 2x squared. So we're going to do the same thing. We're going to pull up the calculator and put those values in there. And see if we can get the same answer. So I'm just going to move this over here, and I'm going to delete these values. Okay, so I have square root of 12 minus 2x squared. My second graph is going to be at x plus 3. And it doesn't matter which graph you put as your first and which you put as your second. So if I graph it, so there's my one graph, there's my second graph. So I'm going to do the same thing. I want to calculate. I want to find my intersect. So it's number 5. So I'm on the curved part there, so okay, that one will work. My second one is when I'm on the other line, x is equal to 0, y is equal to 3, hit enter. So I get x is equal to 0.414, which was the same value I got in the other one. So let's try it for the other point. And do my intersect again. I need to move down though because I want to get, or over. I want to get closer to the curve on the left side. So enter. Okay. Second curve. Oops. Enter. Oh, it hasn't moved on to the other graph for me. Move on to the other graph. This is frustrating me because it won't move to the other line. Because this is still on the curve function. Move to the other one. There we go. I needed to hit the up arrow instead of down. So it's important to watch what is happening up here, because you can see when I did it the first time, I was always on that first line that I put in there. So now I'm on the second line. I can hit enter. It's going to ask me to guess. And I get my point of negative 2.414. So I've got exactly the same answer. Okay, so when you're solving them graphically, you have two ways of doing it on your calculator. You can either put them as one function and then put y your second function is equal to 0, or you can split them up into two. The steps after that are the same. You're going to do the intersect. To do them algebraically then, it's just a matter of solving. So square root of x plus 3, and I put brackets around there, but that's okay, is equal to square root of 12 minus 2x all squared. So in order to get rid of the square root, I have to square both sides. So remember, squaring a binomial, I get a trinomial. So I have x squared, x times 3 times 2 is 6x, and then square the last term so I get 9. And then here I have 12 minus 2x squared. So bring everything over to one side. So I'm going to subtract 12. I'm going to add 2x squared. So I have 3x squared plus 6x. What am I doing? Minus 3 is equal to 0. So I could do slide and divide, or I could just GCF this. I think it'll work. Or am I going to get a weird value? If I GCF a 3, x squared plus 2x minus 1 equals 0. Well, if I do that, I've got nothing to do with product and sum that's going to work. So that means I'm going to use my quadratic formula. So refresher, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So my a is equal to 3, b is equal to 6, c is equal to negative 3. So I have negative 6 plus or minus square root of 6 squared minus 4 times 3 times negative 3 all over 2 times 3. Negative 6 plus or minus 36. 4 times 3 is 12 minus 3 is, where am I? Is 36, so 36 plus 36 all over 6. So x is equal to, just going to make the page a little longer, negative 6 plus or minus square root of 72 divided by 6. So if you punch that into your calculator, if I do negative 6 plus square root of 72 divided by 6, I get negative 2.41. If I do x is equal to negative 6 minus square root 72 over 6, I get 0.41. So those are your two solutions. Okay, last problem. Just going to pause 1 sec. We design a roller coaster with a vertical drop that can be modeled by v is equal to the square root of v o squared plus 2ad, where v is velocity, d is distance, and vo is your initial velocity at the top. A is acceleration. So it says if the speed must be 120 feet per second at the bottom of the drop, and the initial velocity is 10 feet per second, and acceleration is 32 feet per second, what is the distance of the drop? So the first thing you want to do is you want to identify all your variables. So they've already told you that v is equal to your velocity. So they've told us here that the velocity or the speed at the bottom is 120 feet per second. So that is the velocity we've achieved. 120 goes in there. Our initial velocity, they said, was 10 feet per second. Acceleration was 32 feet per second, but we don't know the distance. So if you put this into the formula that they've given you, so v is equal to, we have 120 is equal to the square root of 10 squared plus 2 times 32 times d. So you've got a couple of ways that you can solve this. You could try to do this algebraically, and you would get an answer. Or not algebraically, just using your calculator and using order of operations to solve. You could do this on your calculator as well. So to do this on your calculator, probably the easiest way to do it is just to say that y1 is equal to 120, y2 is equal to 100 plus 64d. So if I put those two into my calculator, so y1 is equal to 120, y2 is equal to the square root 100 plus 64, I don't have a d, it's a variable, so I just use x. I'm going to change my window here, so instead of going to a maximum of 10, because it says I'm traveling 120 feet per second, so I know I need to have at least more than 100. So I'm going to put this, max min can stay at negative 10. You don't have to have a negative there because you're not going to have a negative velocity, but we'll leave it at negative 10. So I'm going to go to 300 on here. Let's go up, whoops, not 300, whoops. Oh. We'll go up by tens. Same thing, you're not going to have a negative distance, but we'll leave it at negative 10. And let's put this one to, let's say 200, just as a guess. And let's go up by tens. So if I graph it, so that is my y1 is equal to 120. And then that is the second equation of 100 plus 64d all squared. All square rooted, I guess. So now I need my intersect of that. So I go into my calculate. Okay, I'm on my y1 equals 120 graph, so I hit enter. I'm not sure why it drew it again. Or did I not? No. I was just looking at value there. I want to go to intersect. So my y1 is 120, so that's on my first curve. Doesn't matter that I'm way over there. Okay, my second curve is y2 is equal to 100 plus 64x. Enter. Give me a guess. And it says x is equal to 223. Or d is equal to 223.44 feet. So what we're doing here is, this is what we've drawn. This is at, the second graph was going something like that. The point where it crossed is what we're looking for the solution. Okay, so it says you can solve radical equations either algebraically or graphically. The solutions or roots or zeros of a radical equation are equivalent to the x-intercepts on the graphs of those functions that you're looking at. You can either use the graphing method to solve, so you graph the corresponding functions and identify the values of the x-intercepts, or you can graph the systems of the functions that correspond to the expression on each side. So this is where you would do, the first one is when you do y1 is equal to and have your whole equation, y2 is equal to 0. This one is where you have y1 equals, you want to say left side, and this one you would have y2 is equal to the right side of the equation. Either way, you're still looking for the intersection of everything.